Hello everyone, today we are going to see about group 18 or group 0 or noble gas. Noble gas that is nothing but that is very stable. Okay. Physical properties are colorless, odorless, gaseous at room temperature. Chemical properties very stable, do not react with other element except xenon. This is exception. Xenon X6. Okay. In noble gas only one exception is there, that is xenon. Noble gas are very stable. Outer electron shell is full. Okay. Uses of noble gas very important. Helium much less dense, lighter than air. Very important. Used in balloon and blimps because it is inertness. It doesn't burn with air. In balloons, in festivals, you see that na? In that balloon, they not fill it by blow. Okay, they will fill it by some gases like helium gas. Very important. Questions will ask. Okay, what is the gas filled in balloons? Helium is correct answer. Okay. A mixture of helium and oxygen is used in place of natural air for divers. Okay. In divers, they use that cylinders, oxygen cylinders. In that, they will use mixture of helium plus oxygen. Very important. Okay. Helium has the lowest boiling point of any known substance. Okay. 4.1 Kelvin. 4.1 Kelvin. Okay. Helium is having low boiling point. Okay. Then krypton. Fluorescent bulbs. F safe bulb. Okay. F is there. F safe bulbs. Flash bulbs. Lasers. Fluorescent. Okay. Neon. Chemical element Ne, atomic number 10. Okay. This is also as usual colorless, odorless, inert monoatomic gas. Okay. Brilliant red glow. Passage of electric current through neon gas under low pressure. In low pressure, okay, we can pass the electric current through neon gas. Electric current through neon gas. Okay. Red, brilliant red glow. Okay. Neon. Okay. We can do one thing to remember this. Neon Academy is there for competitive coaching. Okay. In that academy logo, it is red only. we can memory it like that. Xenon also using fluorescent flash laser. It emits instant intense light and present in discharge tubes. Xenon is like fluorescent. In extra one thing in xenon is tube, discharging tubes. Okay, that's it. Argon filament bulbs, same. Metal filament will not burn in argon. Okay, metal filament will not burn in argon. Argon prevents the oxidation of the hot filament, thereby prolonging its life. Okay, very important. Argon filament. Okay, argon filament. Radon radioactive. Okay. Medicine, source of gamma rays, used as medicine. Small capsules to destroy malignant cancerous growth. Very important. Radon used in cancer treatment. Okay, radon. We know razor, that means blade, used to cut things. If we want to cut the cancer cells, use razor, not radar. Okay, now atomic size is nothing but it depends upon nuclear charge increase. If the nuclear charge is increase, then outermost electrons increase, atomic size also increase. Okay. As we know, this is atom. It have only one outer cell. It is very small. If it has more, then definitely size should be increasing, right? Okay. It increases as we go down. Okay, in group we are going down, because group numbers 1, 2, 3 we are going side, 5, 6, 9, 10 like that. Here 1 to 5, 5 to 7 like that. It's increasing only, right? Then when we are going down, it should be increasing. This is the periodic table, as we know, from going down, coming down, group. This is period. These are alkali metals, alkaline earth metals, halogens. This 18th group is called noble gas. Okay. Ionization potential, that is nothing but energy required to remove an electron from an isolated atom or molecule and make it in the form of iron. That is called ionization potential. Some energy required, right, to remove the electron in the form of iron. That is called ionization potential. It is larger for smaller molecules. Okay, because in smaller molecule only one cell is there, that is very near to nucleus. Okay, that is why if it is very near to nucleus, okay, it is very large number. Okay, in this ionized potential is very large when it is near to nucleus. Okay, important. It is depends upon Number of cells, nuclear charge, increasing the number of outer electrons increases. Okay. If it increase in the outer electron, okay, nuclear charge will increase. Nuclear charge is not even nuclear size, atomic size. Okay. Electronegativity, we measure the tendency of an atom to attract or bonding pair. Okay. Measure of the tendency of atom to attract a bonding pair of an electron. Okay. Here is the how the tendency of an atom. Okay, the atom has a tendency to attract or bond of an electron, that is called electronegativity. Okay, it is easily combined. Okay, fluorine, most electronegativity. Fluid, we know, is used as toothpaste. Paste. Okay. If we are not using, if we are not using toothpaste, we are the negative person in our class. Okay, electronegativity high, fluorine. It is basically depends upon the number of electrons in the outer cell. Okay, it increases as the number of outer electron increases. Okay, if it is depends upon outermost cell, because outermost cell has tendency to attract or lose the electron. Okay, it depends upon outer electron, that means definitely we know the outer electron number is increase. Okay, the electronegativity also increase. Okay, non-metals are electronegative, we know. Metal, we have positive use. Okay, we know na, metal, silver, gold, everything we have positive impact. If it is non-metal, what is the need? We use, this is just for trick here. Okay, what is the use? We no need. Okay, this electronegative. Metal, electropositive. I can give you another example also. If it is a metal, right, easily electricity, it conduct electricity. Okay, then it is electropositive. In non-metal, it couldn't conduct electricity, so this is electronegative. That's it. Properties and behaviors along period, behavior along groups. Okay, properties of element behavior along periods, elements behavior along periods, and behavior along groups. Okay, atomic size decreases left to right. Okay, here the atomic size should be reducing from left to right. Okay, from going okay, electronegativity, right, negative things are completely opposite. We know from size it is increasing here to here, but in negative case size are decreasing. Okay, same, left to right decreases from up to down. Same here, also size increasing, but we know it is negative. Okay, here also increasing. That's it. Ionic bond is a type of chemical bond that involves the electrostatic attraction between opposite charges, plus and minus. Here the outermost electrons has plus ions, here the outermost electron has minus. The plus and minus should be attracted, right? That is called ionic bond. Okay, it involves electrostatic attraction. Okay, primary interaction occurs in ionic compound. Okay, then covalent bond. It is also called molecular bond. Okay, CM, covalent bond, molecular bond. Okay, CM. This chemical bond involves sharing of electron pairs between atoms. Electron pairs are known as shared pairs or bonding pairs. Stable balance of attractive and repulsive forces. Okay, here it is stable. Then okay, it is called covalent bond. Okay, oxidation reaction. It is able to gain oxygen, that is called oxygen, because in by name it is having oxygen. Reduction, definitely opposite is reduce oxygen. I have one trick for this. In oxidation, except that oxygen phenomena, others are loss only, oxygen only gain. Okay, in reduction, except oxygen only it is reduction, others are gain only, hydrogen and electron both are gain. Here loss, here both are gain. Okay, here I can explain 4HCl plus oxygen, 2 chloride plus 2H2O, hydrogen plus bromine, 2H hydrogen bromine. It is gaining on oxygen, it is removing on oxygen. Okay, but this is just for this is just for visualization only. Okay, I can explain each and every reactions in separate video to understand it. Okay, redox reaction, that is nothing but okay, both both oxidation and reduction it occurs, that is called a redox reaction. Here compound A loses electron, here compound B gains electron. Okay, here this is A is reducing agent, B is oxidizing agent. Okay, redox reaction is nothing but reduction oxidation occurs in the chemical. Okay, that's it. Decomposition reaction, it is a chemical reaction, single compound breakdowns into 2 or more compounds, that's it. Examples: ferrous sulfate crystals, FeSO4 into 7H2O loss water when heated. Okay, it decomposes to ferric oxide Fe2SO3, sulfur dioxide SO2, sulfur trioxide SO3, ferric oxide is solid, while SO2 and SO3 are gases. Okay, combination reaction, it is a reaction while single product is formed, 2 or more reactions is known as combination reaction. There is two types, two examples of burning of coal, formation of water, both are comes under combination. Okay, CC, combination coal. Okay, displacement reaction, it should be displaced its position. Okay, here see zinc plus copper sulfate, here zinc sulfate plus copper, that's it. It is just in that zinc position, the sulfate should add here and copper in that particular position. Here lead and copper chloride, here lead chloride plus copper. Okay, it should be just the displacement, displaced his its position, that's it. Here neutralization, when we see neutralization, it is nothing but the reaction between the acid and bases. Definitely salt is the byproduct, that's it. Okay, reversible reaction, we can able to reverse it, that's it. In that reaction exothermic and endothermic energy will come while we are in reversible. Exothermic and endothermic reactions will help. Okay, exothermic, that is nothing but the heat results in the heat. Okay, in that reaction it will exhibit the heat. Okay, in endothermic it will intake the heat and it will change it as it is. That is called reversible. In irreversible, the reactants react to form the product which cannot be revert back. Okay, we can't revert it back. Heat transfer from finite temperature difference, friction, plastic deformation, flow of electric current to a resistance, magnetic magnetization or polarization with a hysteresis, and unrestrained expansion of fluids, spontaneous chemical reaction, spontaneous mixing of matter of varying compositions. Okay. Then corrosion and rancidity. Corrosion is nothing but a metal is attacked by a substance found in the immediate environment, that is nothing but water, oxygen, like that. Okay. Moisture, it is called corrosion. It can weak the iron something. Okay. Black coating in silver, green coating in copper, these are the examples. Oxidation, deterioration of a metal surface, the environment is called corrosion, or electrochemical process. It is a electrochemical process. When air exposed to the air, the surface turns brown due to the formation of hydrogen peroxide. Okay, this is important. Also called rust. Okay, rust is nothing but hydrated ferric oxide, sorry. Okay, this is called rust. Rancidity is nothing but fat or oil getting oxidized. It is known as nothing. In childhood, mummy pack food. Okay, she dump the food and very lot of in form of love. She is putting very lot of food in our lunch. Our stomach are very small, right? We can't able to complete that. What can we do? We put the remaining food in that box, and we bring it back to home. Okay, half food. Okay, when mummy will open that, bad smell will come, right? Bad smell. That is because of rancidity. Okay. Okay, tomorrow we will see about combustion and flame. Here I am going to wind up this session. Thank you for your support. Please continue giving your support. Subscribe for your upcoming videos. Thank you.